because I see it's already 10 past. So to continue where I left off, inheritance is when one class um, is formed from another class. So like you are formed from your parents. We're gonna have a shape, but a circle is a shape. So the circle will take the shape's attributes, yes, but the circle will also have its own attributes. Does everybody understand? Let's use in this class. Does everybody understand what I'm saying? Okay, cool. Let's continue. Let's make a new project. Where's the saving to? Cancel, cancel, cancel. Let's make a new folder for it. Let's call it 1408. Let's call it set the inheritance. Next. So I spoke about inheritance, but there's also something we need to speak about, which is called um, polymorphism. Can anybody tell me what polymorphism is? And while you guys are typing in the chat, let me just continue to finish this. Okay, yeah, that's okay. That's okay. Let's just remove this part. Finish. I mean, I didn't want it to do that, and I literally just removed it. Can anybody tell me what is polymorphism? I can see you guys don't attend class during the week. This thing is still on the disk. CSC. No, desktop. Set it touch 1408. Delete this. Yeah. Nobody, I don't hear any comments popping up. Nobody knows what inheritance is. So, to give you all an explanation of what not inheritance, polymorphism is achieved when you have an abstract method declared in a class but only gets implemented at a later stage. Yes, is many, so I think it's associating many meanings to one function. Yes, so we define a function and we don't implement this function because each function is going to be implemented in its own unique way, but we need this function to be in all of our classes, but each class implements its own function. For example, what we're going to do today is we're going to have a shape, right? And the shape has a draw method, but we don't know what a shape is. Can anybody tell me what's a shape? It's just a shape, just their sides. You don't know how to draw it. You don't know how many sides they're going to be. Nothing. Is there a radius? No. What's the angles? You don't know. Is it 3D? You don't know. So we have a draw method in our shape class, but when we, let's say we're going to have a circle and a rectangle, let's say we want to draw a rectangle, but we don't really specify um, that we're going to be using the rectangles draw method. What we do is we call the shapes draw method, right? And what the shape will do is it will polymorphically look through the definition and be like, oh, okay, I'm drawing a rectangle, so let's go use the draw function of the rectangle. Or I don't know if you guys use if you guys are doing informatics too. I mean, not informatics 2, informatics 1B, but It's the same as an abstract method. It gets defined later on based on the implementation you provide for it. So let's continue, guys. Finish uj image, and then let's go define. Let's just okay. Wait, let's do this. Let's make a new file again, and let's call it the common library, right? And in our common library, we're going to have the general stuff here, which is the RGB color, and it's gonna be int red, int green, int blue. I heard a. Do we use the throw method and reference the shape we want to output? Given the class, given that we have a class that will give the method the features of the specific shape we want to throw. Do we use the throw method and reference this? Yes, yes, yes. Or you just polymorphically invoke the throw method from um, you will polymorphically invoke it by just saying, let's say you have a shape, right? And then you would say your shape dot throw. Okay, in Java it would be dot throw, and then you specify the image or whatever you want to draw. And let's say your image is of type um rectangle or whatever, then it will draw a rectangle. Or if it's of type circle, it's gonna draw a circle, because the compiler will figure out, okay, we don't really have a draw method implemented, but this function has the same name. Actually, it's what the compiler does is it will automatically it will achieve polymorphism automatically by just going through the definitions of the function and being like, oh, I see this one is passing me a rectangle, and then I will draw a rectangle. The next is gonna be our status codes. It's all boilerplate code. If success. Oh, guys, excuse me if I yawn. I am not feeling well today. We have a range, right? I think that's about it here. And then let's go back here and include let's include what we just defined. Common. And what else do we need to include? I think we need to include the string library, because we're going to be using basically the same. Is it C string or is it just string? I think it's string, just like that. And it's using namespace standard. Alright, and then now let's define our class uj image and set uj image. Didn't mean to do that. Let's go. Let's start with our public members, and this is everything we want to make public. Let's just shift this over here. We're gonna have our default constructor, which we don't really have to focus on from now on, because uh, int rows int calls, and then let's just copy this, and then let's add a RGB color rec default save, and then we need our string to ppm function, right? And after that we need some access modifiers, but let's first do this. Let's go private. What do we need? We need an array of pixels. So this is the basic stuff you guys should be uh, already comfortable with. It should be becoming more familiar now. And we have our helper method, which we normally have int value, int min, int maximum, and it's gonna be a member function. The question. No copy constructor needed. Oh, I forgot the copy constructor. Let's just put it in there. But the focus this week isn't on the copy constructor at all. The focus this week is on object original, transfer original. The focus is more on inheritance and polymorphism, which is quite easy. I found this part of the course very easy. And then let's do our accessors. So we're gonna have one for the rows and get rows, and get calls, right? And what else? We need to get our pixel. So get pixel and a specific row and a specific column. It's gonna be a member, and then we need our mutators. Just make a comment there. So now it's gonna be set rows. It's actually a void function. Set rows, and we're gonna give it. Is this a member function? No, it's not. Void set calls. I'm gonna give it your int calls, and then we're gonna void set pixel, and we're gonna give it an RGB color. Um, Actually, we need a row and a column first. I'm gonna give it RGB color. Rec world. I think that's about it. No, we don't have to make this. Don't think so. Let me just check to make sure. The question: do we set rows and columns in the constructor? And the no, and the yeah, I will implement this. I just came to check the question. Thank you so much for engaging today. Don't we set the rows and calls in the constructor? We do, but sometimes you want to change it during runtime. So let's say you instantiate your object, right? But you don't want your image to have like such a huge um, size. So we set them using our mutators. It's perfectly up to you, but I would suggest you practice your object orientation and just write them out because it's just good practice. I mean, like in third year, you still okay. We don't really implement accesses and mutators. I mean, like they give it to you, but if you don't know that you have a mutator or an access, an accessor for a certain field, you won't really get that practical working at all because in third year you have like 3 hours to complete your practical and you have to do it in the labs. Okay, online it's a bit different. They are a bit more lenient. They give you like an extra hour, I think. So you have like 4 hours to complete it. The extra hour is because of things like load shedding and the computer being slow and whatever. So, yeah, so after this, we need um our constant. So let's go static const, and then I'm going to copy this so I don't have to do it the whole time. Or actually, static cost in, so I don't have to type it out the whole time. Default underscore rows. So used to we I should have set this. Let's say default rows is 10. And then mix dimension size. Let's make this 10,000. If I think that's 10,000. Actually, don't care as long as it works. And then we have our max intensity. We're going to be using this probably when we enforce some ranges. And then lastly, like Mr. I don't know what's his name, Mr. Singo said, we need our destructor. Take my caps lock off. Future image destructor, right? And that's about it. Let's just copy all of this over. Let's just copy all of this. Do we have an implementation file? No, we don't. Let's create our implementation file. UJ image. And then we're gonna need to let me just paste all of the stuffs. Take that one. And let's just include all the libraries we need. So we need to link the files together. So that's what we'll do here. And then I think we need our stream, and then we need our IO stream. Right. Uh, yeah, we need our IO stream. And then let's just delete this, delete. And I'm gonna copy this. And then I'm just going to chain this method to our other constructor, and right. Let me just copy this part. This one we're gonna be doing the same thing. We're just going to chain it to this constructor over here. So see v, and now we just call this int rows. Why is it not getting the scope? I don't understand. seems about right. And then let's do this one. So now we actually doing the regular thing. It's gonna equal to our. This is where we do set it. We do set it here, and sometimes we want to change it. So it's just good practice um to have it around, to have your accesses and your mutators around. Let's just set everything first. Gonna equal to a new RGB color pointer. Um, is it a pointer? I've been coding so many Python programs this week, I can't remember. But I think this is how it works. So the is used for changing, is chaining used to link the code. So chaining, let me explain chaining. So when you chain, when you chain a method, you're telling, so when I call this UJ image, this, let's say I'm calling this one. Let's say I'm just instantiating this one. I'm using this constructor, the default one. When I call this default constructor, it will go look into the code, and it will be like, okay, this is the definition, and it's telling me that I should use this function instead of my own. You can have your own, you can still chain it and have your own things, like set your own stuff, but you chain it because you don't want to be repeating what you write in this constructor in this one here. You get me? So you'd rather just, it's kind of like, it's not delegation. Let me not confuse you guys and say it's delegation, but it's like you delegate. This function is telling the compiler that, hey, instead of using my thingy key, can we just use this guy's one? It saves time, and it helps your program structure look a bit more better, because imagine rinsing and repeating this code each time in all of this constructors. So that's why we chain our constructors. You can even chain a method to another method if you want that method to use that method's method. Sounds confusing, but yes, that's what I mean. And then let's have a for loop. R is less than. Did I put the less than sign? R is less than int rows. Was it underscore? Let's use underscore rows. Let's use the class one because we just set it. So then we know if it's not working, is it breaking? And then, so we want to, so row, at each row, we want a new RGB color array of underscore columns. And then we're gonna have another for loop. Underscore calls C++. And then we're gonna have your underscore pixels. The row and the column is gonna equal to rec default. So we're making it white basically. That looks right for that one. Our copy constructor, 3 marks. I don't know, I forgot if you guys are writing a practical semester test. So all of this boilerplate code here is gonna get you 3 marks. Like even the constructor training is gonna get you 3 marks, trust me. So if you're aiming for a 50, do the basics. If you're aiming for 75 for distinction, do the basics in some logic. And it's the same as in computer science one way. If you just implement your basics and make sure your basics compile and everything's working, and then you have like some game logic, or yeah, it's gonna be some image logic, because you're definitely gonna be given like um, 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 a scenario where you're gonna have to be using composition, inheritance, and polymorphism, and then you're gonna be drawing an image. You're gonna be sending it to a PPM image. So that's what it is about. Can I zoom in? Okay, I'll zoom in. Sorry guys. So if you want to get the basics done, so this first part, like your accessors, your mutators, all of these things are basics. You'll get like a 50 if you can get that part working. And like your inheritance and your poly, I'm gonna show you guys where you're basically going to get your 50 from. But so far we can say we have like 20%. Our copy constructor. Um, I think we can also chain this one. Yeah, let's chain it. Let's chain it to this constructor over here. Ooh. And then we're gonna give it object obj original original. I don't know why it's not referencing it, but it's probably gonna give us some problems later on. And then obj, oh, we clicked it now. Yeah, let's chain it to this constructor, and then let's just make our deep copy for. Let me copy this for loop header. Copy this for loop header. I'll attend to your question now, and then underscore pixels row row and a column is gonna equal to obj original dot underscore pixels row column. Cool. We done with our copy constructor. Let's, what is rect default? Where was it initialized? Rect default. Let's go here. It's just a parameter type is specified here, and it was not instantiated at all. However, when we do provide, this is basically the default. So you can say rect default is this, but because we busy with a declaration, or rather, this is the prototype, and this is the implementation. So whatever you're going to pass into this function will be called, or will whatever you pass into this section over here will be your rect default. So let's say you passed this into the function. Let's say in your main here, you go rect default or whatever, or you make like a RGB color for yourself, and then when you call the constructor, you pass that RGB color in this place. So that's where we get our rect default from. Let's finish off. You so to ppm. So we need our stream. Let's call it ss, and then we're gonna go ss ppm. We're gonna type. What else? We need to specify the color range. I forgot the rows. I forgot the rows. Let's just do this here. This one. and then we're gonna have our for loop headers. For the guys that joined late, can you please not use the code given to you in the tutorials for your practicals? I'm not saying don't look at it or don't try and understand the logic. The logic is given to you, but please do not submit it. Like we're going to see it, and the copy checker picks it up anyway. So what am I doing? What am I doing? No, I am not in the copy constructor. What I'm supposed to be doing now is supposed to be typing components of our pixels at that specific row and column. At that specific row and column, we need our red, space it out, and we need our, let me just copy the whole section, make our lives easier. Right, and then at the end of each column, we want to type in an end line. Right, I think that is our function, and then let's just return ssp dot to string, or is it dot string str. I'm not sure. This is probably gonna complain later on. Right, and then we're gonna have our, is a question. Line 48 end line, please check this. Line 48. Thank you so much for that. That's probably gonna bug me earlier on, I mean later on, and then I don't know how to fix it, so we're just going to return underscore rows. So we didn't implement our enforce range yet, but let's just say we're going to enforce the range, and then we want to give it int row first, so 0, and then underscore rows. And then what we're gonna do, we're just going to return underscore row, the array at int row and int column. Yeah, I think that's about it. Yeah, cool. And then let's implement set rows one. So we first need to enforce the range and make sure that the in rows is not less than 0 and not greater than the number of rows. That's the maximum number of rows. And then what we're going to do is we're going to go underscore, no, max dimension size, max dimension size, thank you. And here we're just going to go underscore rows is going to equal to int rows. Makes sense now. Other question. Isn't the rows minus 1 and columns minus 1 in the enforced range since we start counting from 0? I don't get your question. I didn't implement enforced range yet, so and as long as it doesn't surpass this number, like the specified row mustn't surpass this number. It cannot be greater. It can be equal to, but it cannot be greater. So I don't know why you're minusing 1. Because minusing 1 would be like the one just before the maximum number. But I understand your logic. Cool. Yeah, and that's what we're going to do there. Let's go quickly and do this. Let's see, we have like an hour remaining. So we want to set columns, we're gonna do the same thing here. Set columns, we're going to do the same thing. Just gonna change this to in calls, and we're gonna make this underscore calls, and this is gonna be in calls. Right, and now that's our set calls. I think we're done the then now our set pixel. So we're first going to enforce the range to make sure the row is specifying is not greater than the maximum number of, right? Then we're gonna make sure the column is underscore calls, and we're going to make sure, let me just do this, it's playing on my R side, and then we're gonna do for the intensities of the RGB colors. So we're gonna go red world, but the red mustn't be greater than, mustn't be less than 0, and mustn't be greater than the maximum intensity. Right, and then what we're going to do is we're just going to say underscore pixels at this int row, no int row, at this int column is equal to your red pixel. I think that's about it. And then we need to do our enforce range function. Let's go back here. Let's just take this and then the destructor. Actually, no. Before. So I'm gonna do it quickly. Let's just get this for loop headers here. Rows. So it's only one of them, ne? Yeah. Because we just need to delete the pointers to each column. Is man go underscore. So, yeah, it's pixels. I don't know why it's not referencing it. Okay, okay. And then let's do this. I wanna delete the entire pointer. And here we're gonna say if the caps lock off, if int fail is greater than your maximum, strictly greater than your maximum, and we're going to say see error, and type some error to the user, and we're gonna say the int fail is greater than, let's put the space here also, then your int maximum, and then we're probably gonna wanna exit, and then let's just copy this over and switch the signs around. Ooh, I think we are done with the UJ image. Let's go and create. Let's just compile quickly. I knew it's going to complain. Invalid pre-processing. Include the string library. Compile. The expected what? Let me not debug this now. Let's go and create the new. I will debug everything at the end. Let's go create our shape. Our shape. Let's create our shape. Question image. What about the image? Oh, thanks for that. I think it should compile now. Please compile. Unable. Cool. Thanks for the help. Let's create a new file. Let's call it our shape. User shape. Right. And then we're going to. This is going to be the start of the inheritance part, right? So let's define a class. So let's first let the UJ shape know that we have a UJ image, right? And then after we let the shape know we have a UJ image, we're gonna go set up our UJ shape class, and um this is going to be the class that we inherit from, and we probably just want to have a UJ shape again, and then another UJ shape in the row. I think I should actually just copy. I I don't know. I don't want to break things in, and I don't know how to debug them because it's gonna waste time. I see it's almost due. Um, and then we will use the shape again. And then we're gonna have, Oh, we don't have to. Just need the RGB color. What else? We need the set color. Oh, we do have a set color. We need a draw method. So this method is going to be the one we call polymorphically. Just remember this. Let me just do this. Polymorphically call this function, right? And then after that, so we're gonna have our virtual functions, because these functions must be overridden by the functions we define in each class that inherits the shape class. So the first one it's gonna be is, I don't like the syntax for this. Like in Java, it's way easier. Like you just say abstract. It's an abstract method, and because the method is abstract, you cannot instantiate an abstract class, or you just type abstract class, like literally abstract class. But no, C++ wants to be funny. It wants to teach you good manners, and certainly it did teach me good manners. And we set it to 0 to make it a pure virtual function, meaning the compiler will not, like, how can I say, assign a pointer to this function in memory, because it's gonna be overridden, right? And then what else do we need? Is in shape. I'll give it the int row, int column. Sorry guys, just had to mute for a moment. People are disturbing me. We don't need that. We just need to know the row and the column. And we make it a pure virtual function. And then we just have our normal static const in default. Should have made a struct for this, or enum. Oh, a struct, yeah, to store the default rows and the default columns. Default underscore row. And then we're gonna have our destructor, which we're going to make virtual, because we're not going to implement it. And now we're going to be introducing like a new access modifier. So these are called access modifiers, public, private. The next one we're going to learn of is called protected, right? And when something is protected, it does the same thing as private. However, when something is protected, the class that inherit from it can also access the protected data that you want. So instead of having to use the access modifiers, whatever inherits from it um, will be able to see, will be able to see and use it. So if it's private, it won't work exactly the same, because you're going to have to use functions to access whatever this is in the function. So normally with private data, you need to have a function to access the data if another class wants to use it. So you'll use your access modifier, I mean your accessors and your mutators to get it, like you get row and you get column. However, because you don't want to use this classes, because this is an abstract class, you can't even instantiate it. So because you want this to be the whatever you put in here to be accessible amongst the other classes, you will do it under a protected access modifier, and whatever class inherits from this will have free access without any problems to this class, right? I think that's it. Let's create our implementation file. A new file. What's the time? I see I'm running a bit out of time. Let's just speed it up a bit, and let's call this UJ shape. Save all, finish, and then let's just let the source know that we are dealing with the UJ shape, and then let's do our constructors quickly. Not gonna do that. Is there a copy constructor? I see there is one. No, there isn't. There isn't. There isn't. Yes, there isn't. Uh, let's do it quickly and swiftly. Let's just copy this and then go view. Let's do it for all of them. So yeah, let's just change this to the other user shape constructor, and what it's going to be asking for the default underscore row. Don't know why it can't find it. Default underscore column. That I didn't do. Here's it. Don't know. Don't know. It doesn't complain. It won't complain. Hopefully it won't complain. Then let's just have this right, and then have a scope for that. We don't really need to implement anything there. So to explain more, it's only clicking now. So to explain more how construct chaining works, or chaining of functions work. So it will come, let's say you're calling the UJ constructor, UJ shape constructor, and then it will first go into this function over here, and then do everything it needs to do, and then it will come back here and it will look in the scope of this function. And let's say you hit underscore row is equal to wara wara fish paste, it will go set underscore row to whatever you set it to, or whatever logic you write in here. So we don't have to write any logic in there because all the logic is going to be in here. I think you're going to still learn chaining. You're still going to use chaining better off sooner. I'm not sure. I need to change this one to, and then this is in row in column, and then do nothing in there. Then we have our main one, right? And what we're gonna do is we're gonna say underscore row is equal to in row underscore column is equal to in column, and then underscore color is gonna be our rec color. I think that's it. I think that's it. And then what else? I think that's it for this one. Let's just do the access not access modifier. Um, we're gonna return underscore row here. Oh, just asking. Set color, we're going to return underscore color, and in the set color, we're going to enforce the range, but we don't have to right now because of time constraints. We're going to go, it's what it is. It is what it is. And in here, um, we're going to need a few for loops. Do I have? No, I don't have any for loops in this. List in the image dot rows is get rows. You see, now I have to use get rows. Get rows. Hey, get rows. Is it? And then r plus plus. I'm gonna do the same for the columns. Right, and then what we're going to do is we're going to be calling the isInShape function polymorphically. So depending on the instance in memory, the appropriate isInShape function will be called, right? So we're going to go if is in shape the row and the column, right? We want to set the pixel. Let's set pixel to the row, the column, and the color we are providing, right? That's about it for this draw function. We're going to be polymorphically calling the other ones. So to demonstrate inheritance before the tutorial ends, I know you guys are waiting long for this. Let's see who's still here. Connection problems. Alright, but the recording will be available after a few minutes after. So let's do our inheritance, right? Let's create a header file. Let's call this our UJ circle, right? And then what we need to do is we need to we need to let the UJ circle know that we have a UJ shape class, right? First of all, and then we're going to say class UJ circle, and there's different types of inheritance. Inheritism. There's different types of inheritance. So you have public, you have private, and then you have protected inheritance, right? For now, let's just use public because explaining the others will take too much time. UJ shape, right? So what we're saying is we publicly inheriting all of what we defined in here, all of these things here. We inheriting it, right? We inheriting all of it, right? So we already have a basic structure for UJ circle. Like right now, it already has a basic structure, but a circle has its own attributes and stuff and methods. So what we're gonna do is we're just going to have a constructor, right? We're gonna give it a row. We're gonna give it because we want to know where to start drawing it. Where is the center of the circle? Uh, and then we're going to give it a red color, and then we're going to give it a radius. Let's just stick to the naming convention, right? And then now we need to have concrete versions of, let's just close this quickly. So because we're going to polymorphically be calling these functions, because these are pure virtual functions, meaning that there's not even a pointer in memory to these functions. The compiler ignores it. It's only going to look for it at runtime. So now we need to have concrete versions of the functions in the base class, our super class, in other words, our parent class, in whatever terminology you want to use, is in shape. Obviously, it still needs to be defined the same because the compiler needs to know um, what type of method is going to be polymorphically being called, and then we're going to go, So now we don't want anybody to have the specific data. So now we keep it private, and we're gonna go. We need a distance calculator. Int x1, int x2, int y1, int y2. Gonna return a double, and then we need a radius. Right, let's create an implementation. What we're gonna call this uj circle. Save that, and then let's just include uj circle, right? And then we're gonna need the math library also because of the distance calculation. And then let's just copy our things over. Just have to delete this part over here, right? And then copy. Uh, right? And then what we're gonna do is we're gonna chain this constructor to our uj, to the parent classes constructor, because we don't want to really specify, because it is a shape, we can already instantiate a shape, right? And then whatever we have in special, we will just um, add it as extra, you see. So we chain it to the uj shape, and we give it a rec color, right? So let's just go rec color, right? And then here we just go the radius is equal to TBR radius. And I need to copy this. It complaints. Ooh. So that's what I meant by it's first going to instantiate the object, and then it's going to come back into the scope here and be like, okay, we need to set the radius into whatever there. So that's why we do constructor chaining. So now with the area function, we need to have our own um, concrete version of it. So let's go. We're gonna go because it's a circle. It's gonna be 3.14. Let's make it a bit more accurate. No, let's leave it at 3.14 multiplied by the radius, multiplied by the radius. Right? Don't you think that's the area of a circle, guys? And then we can, here we need to return distance from the row to the images row, and then from the column we want to the now with you guys, and then from no return the distance. So this is a boolean function, right? So it's going to return a true or false, right? So it needs to return a true or false. So the only way to convert this into a true or false is if we do something like this, less than and equal to the radius, then we know underscore radius. Then we know it's in the what's the name? 15 minutes left, guys. It's right. Yeah. Um, so now this is a comparison. So what it's going to do is it's first going to calculate the distance and it's going to check if it's less than the radius. If it's less than the radius, then we know the pixel is within the shape, right? And then this is just easy. Get the radius. We're just going to return underscore radius. And then here we need to we need to just use our math function. So we're going to return the square root. I think we need to say using namespace standard here. I'm not sure because it's going to complain. We need to return the square root. Yeah, that's why it's not. So this is your distance formula. So it's gonna be int. Oh no, x2 minus x1. It's gonna be to the power of 2, right? If I'm making sense, it'll be y2 minus y1. Yeah, making sense. Let's just put some spaces in between because it's confusing me. I hope it's not confusing you guys. Okay, cool. Let's compile everything. A non-member function. Which one is it complaining about? Control C, Control Y, Control Y, do this. But it is a member function. Oh, undefined reference. Undefined reference. Hmm. But however, guys, this is how. Oh, it's still 14:35, so I have some time to debug this. Um, let's quickly. No, let's debug this. Why is it complaining? No, this is right. I think I did do it right, guys. I'm not sure what I did wrong. Hmm. 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 Because it knows about it. constructor. Do we need to implement one? I mean, what's the name? Do we? Any help, guys? Mr. Single, try doing forward declaration of UJ shape in UJ circle. So you're saying that we should do this. Class. No, not in this one. In the circle. Close to the left, yeah. Let's go here. No, wait. UJ circle. This is where it's complaining, right? So let's go class UJ shape. Wow. Still saying undefined reference. Can be a bit iffy this. Let's see if I remove this. You see it's going to complain. Anyway, let's write the main function before it ends. So, and then we debug together. So what we normally would do is we're gonna test our constructor. So we're gonna go uj image 100, and let's make this white. Oh, it's black. Let's make black, and then let's make a new uj shape. I think I did something in my uj shape that's wrong. Let's make a pointer to it because we cannot instantiate um, uh, right is gonna equal to a new uj shape. No, circle, and then we're just gonna provide 250 and 250. Then we want to give it a color, so let's make it, I think this is gray, and then 50, 100. Oh, am I putting too many things in it? No. So it's 250. We have our record struct here, and then let's say the radius is 55, and then circles area. So this is where we're achieving our polymorphism. So we're gonna polymorphically call the area function, right? So we do that, and then we're gonna go obj shape, and then we're gonna dereference the pointer, and we're gonna call the area function. That's all we have to do. Don't have to specify anything. It's literally all we have to do. And then let's just call the draw function polymorphically. So we're gonna go obj shape, and we're gonna do this, and we're gonna say draw. All we have to do, and we're gonna give it our object image, obj image, and that's about it when it comes to polymorphically calling functions. That's all you need to do. You call the original one, it's gonna go, so it's gonna go into the uj shape, it's gonna come in here, it's gonna say, okay, draw is a virtual function that I did not, isn't it supposed to be virtual? But yeah, it's gonna come into the draw function, and it's gonna say, oh no, but draw is not supposed to be, yeah, draw is supposed to be implemented. So gonna come into the draw function, and it's gonna set the images. Um, it's gonna set the pixels in the image at that specific row and column, and then what it's gonna do is it's going to here. Where is it here? Here, it's gonna polymorphically give a definition for this function. Do you understand, sir? It's gonna polymorphically give a definition for this, and then because it's a circle, it's gonna come to a circle, it's gonna be like, okay, let's use u, and then we come here to the circle, uj circle, and it's gonna say, it's gonna return whether or not it's in the shape or not. So it just depends on how you implement it. Ah, cool, you understand. That's great. I'm still trying to see where is the problems. Okay, so we need to include the uj image, and we need to include the uj circle, and what else? We have the IO stream. Cool. Let's compile. It's gonna complain. Expected comma. See out. Don't know what it's complaining about. Do you not know what it's complaining about? Am I missing a semicolon? Line 11. Semicolon line 11. So stuck with this. Hmm. I don't know. Let's check my notes. That's the only thing I can do. Uh, let's see. Okay, I have the circle. Let's go to shape. Because the rest is alright. Like literally, the rest is okay. This is this is how you're gonna polymorphically call the functions, right? This is your poly. Can you see? I'm not creating a uj circle object. I'm creating a shape object, and then I'm just using the shapes draw. I mean the shape. I go. I dereference the point and I say I want to use the area function, and then when it goes into the area function, yeah, it's gonna see, oh, I am a pure virtual function, so we need to see what type are we. So it's gonna check that, oh, I'm a circle type, and it's gonna go to the circle, and it's gonna be like, oh yes, the area function. So let's go into your implementation, and let's return your area. Um, I'm still confused on why this is not working. Like literally confused as to why it's not going to work. We need to include UJ circle in UJ shape. No, not necessarily. I don't think so. Undefined reference to the user shape constructor. Do we need to implement a constructor? Let's see if we implement the constructor. Let's see if we just define it, it's gonna stop complaining. Still the same area. Error. Wow. So the circles area is this. Cool. Um, I don't know why to do that. I'll have to check my notes, but that's about it for today's tutorial, guys. That's really about it. Hey, is it because I did not implement the constructor? Yep. And then let's implement this. And because there isn't any pointers or whatever, we do not need to. Ah, ah, I thought you're going to work. Is this really what you're going to do to me right now? Is this really what you're going to do to me? However, it is. Any other questions, guys? My two loyal students, Mr. Singo and Mr. Boysensai. You guys are loyal. Any other questions, my guys? Or girl, guy and girl? Don't know. UJ shape. Thanks for the lecture. My internet is giving problems. Yeah, you are free to leave, guys. If there's no questions, you can leave. I just want to debug this and see what's going on. Is it virtual? Trying. Yeah, an abstract class must have a virtual distractor, even if it doesn't have any pointers or code inside it. Mr. Singh, if you don't have any questions, you can be you can be gone.